Okay, so one of the real-time scheduling algorithms is called earliest deadline first. So what does it mean? It's also abbreviated as EDF, of course. What does it mean? The earlier the deadline, the higher the priority. Okay? So if you want to see something that is being scheduled, well, unfortunately it's not here, but let's go and see a problem of our own. So let's go here, examples. Let's here define a problem. All right, let's take it this way, that's enough. Okay, and let's say here I have P1, P2, P3, P4, P5, okay? And here, this is, of course, the processes that we have, as you can see, okay? And let's say you have arrival here. You have burst. And you have deadline. I'll just write DL, okay? All right, let's do that. So you have here the arrival of P1, let's say 3. Okay, that's P1. Okay, the arrival of 2, that's let's say whatever, 4. Okay, 4. The arrival of P3, let's say it's 6. The arrival of P4, okay, let's say that would be a 7, and the arrival of P5, let's say 9 or whatever. The burst here, the burst is 5. Okay, the burst is 5. The deadline for this one is 12. Okay. The deadline for 4 is 10. The deadline, P2, and that would be just 2. Okay. The deadline for P3 would be, let's say the burst is 4, and the deadline here is going to be 12. Okay, P4 arrived at time 7. It has a burst of 3, and the deadline here is 14. P5 arrives at time 9, and the burst here is 5, and the deadline is 17, as an example, okay? All right. So here is time 0. All right. From 0 to 3, there is absolutely nothing, so this is idle. From 3, there is an arrival here, P1, with a burst of 5. The deadline is 12, but that's the only one we have, right? The deadline here is kind of meaningless. So this is going to work from 3 to 8, P1. And P1 meets the deadline. Why? It finished at time 8, whereas the deadline is 12. At time 8, look what we have. Let me just play with the numbers a little bit because, okay, this is 16. All right. So we have P2 is there because it arrived at time 4. It's now 8, as you can see. We have P3 arrived at time 6. We have P4 arrived at time 7. We don't have P5 because, as you can see, it arrived at time 9. So out of P2, P3, P4, the obvious selection is P3. Why? Look at the deadline. Here there is a deadline of 16. All right, here is 12 and here is 14. So the obvious one would be P3. P3 has a deadline of 4. Let's start it from 8. It will work 4. Okay, that's P3. P3 is done and it met the deadline. See, it's done and met the deadline. Barely made it. Look, it finished at time 12. And the deadline here is also 12. Then, at time 12, I have all of them, as you can see. Who is the earliest deadline now? This one. It's 14. All right? So P4 will start from 12. It will finish at time 15 because the burst is 3. Look, P3. What is the burst? Oh, sorry. P4? What is the burst? 3. So it will start at 12. It finish at 15. So P4 finished, but it did not meet the deadline. It missed the deadline. So at time 15, I finished now P1, P3, P4, as you can see. I have P2 remaining, and I have P5 remaining. Okay? Now, P2 has a deadline of 16, and P5 has a deadline of 17. So, of course, I'm going to be selecting the 16. It's the earliest deadline first, with a burst of 2, so it will finish at time 17. That's P2. It finished execution, but it did not meet the deadline, as you can see. Now, the last one is P5. It's going to start working at 17 when the deadline is 17. So, definitely it missed the deadline here, 23. So, that would be P5. It finished the execution, but it did not meet the deadline. As you can see here, the domino effect. One missed the deadline. The following ones also miss it. Why? Because those processes have a very short slack time. Okay, what is the slack time? Look at that. Let's assume that you have a process P arrived at time 5. Okay, so the arrival is 5. The burst, let's say it is 6. Okay. The deadline is 14. Okay. So at time 5, that's the arrival of the process. Okay. If it starts at time 5, it will finish at time 11 because the burst is 6. And 11 is completely fine because it finishes before the deadline, which is 14. Perfect. If we start at time 6, we will finish at time, the burst is 6, so 12. 12 is also absolutely fine because, you finish before the deadline. If you start at time 7, you will finish at time 13. 13 is also absolutely fine because it's before the 14. Now, if you start at time 8, you will finish at time 14. You barely made it, right? If you start any later than 8, you will miss the deadline, right? So, what is the slack time here? Look. And here, this is the slack time. From 5 to 8. You can start at 5, you can start at 6, you can start at 7, you can start at 8. No later than 8, otherwise you're going to be missing the deadline. So how big is your slack time? 3, right? 3, 5 to 8. So this is what we call the slack time. The bigger the slack time is, the higher the probability that you will meet the deadline. Okay? All right. I know this is not written in the book or probably any book, but you are responsible for it. You will be asked about the slack time. All right? Okay. So what is the slack time? If I want to write an equation for it, let me figure it out. It would be the deadline, okay, minus the arrival, minus the burst. The remaining time of this, the deadline minus the arrival minus the burst, would be the slack time. Now, if you calculate the slack time in the beginning and it's negative, you will never be able to meet the deadline. Done. If it's 0, then you will barely meet it. Okay? If it's positive, then you have a chance. Okay? So we can use this slack time to figure out which process we want to drop to minimize the processes on the load of the the scheduler. Why? If the process is missing the deadline anyways, all right, so if the slack time is minus, okay, so it came dead already. Don't deal with it. Skip it. So you give a chance for the others who have a slack time of negative or positive. All right. All right, so this is how it is. Okay, now if you change those values of the deadline and give them bigger values, so instead of 12, that's 15, and instead of 16, that's 20, and so on, you will find that those are being met. Okay, especially, of course, for P4, P5, and P2 and P5, okay? They will meet the deadlines if you push the deadline farther. In other words, you give a bigger slack time.